Okay, so when we left off, I think we were somewhere around section 3-3, dealing with SOHO routers and the functions of a SOHO router. A SOHO is small office, home office. So it's not necessarily just your house. It could be a small office, like a small insurance agency kind of thing. Let me jump over to screen share. Okay. So here we are in this setting up a router. Now, there's things that we need to take into account before we ever go to do anything about setting up this thing. We got to figure out, I think the analogy I used before is like going to buy a car. Before you go to buy a car, you need to figure out, and I shouldn't say car, I should say vehicle. Before you go to purchase a vehicle, you need to have a good understanding of the utility requirements of that vehicle. Utility, oddly enough, there's a measure of utility. You can measure utils, and it's not something we'll get into in this, but it's look at it as a standpoint or the perception of what is that resource going to do? What functionality and purpose does it have? What role does it play within the system? Now, when we look at the roles in the system, if we're talking about a vehicle, if I'm going to haul 4 yards of fill, I'm not doing that in a convertible. So if I know the purpose, what it's going to have to do, the functionality, that will help me when it comes to knowing which one to acquire. And I have to document this before I ever buy it. I need to document what's it going to do, how many users, how many, we need to take into account scalability. I may only have 5 users today. A year from now, I may have 500. So I need to know, is the system going to be scaled up? Am I just going to have one and it's not going to grow? These are questions I need to ask ahead of time. These routers, as I talked about last time, they will dole out or provide IP addresses to the different users. They'll have on one side the IP address that you receive from your ISP, and on the other side, it's IP addresses on our subnet or our little network, if you will. There's an image of what it may look like. These routers may have just physical connections, or they may have wireless connections. Doesn't matter if it's a physical or a wireless connection, they all have IP addresses associated with them. Now, it's not necessarily that one connection has that hard-coded IP address associated with it. It's just a place for you to connect physically to the device, and then the IP address is then assigned to that user that's connected through it. So I could have one wire connected to one port and 15 users connected to it. All right. So with that said, I need to know what it's going to do for me or my organization, how many users, how many connections, who's going to manage it. One of the things I said last time was the system is only as fast as its slowest component. So am I going to buy an 8010, excuse me, am I going to buy a .AC or a .AD when it comes to the IEEE protocol for the wireless network? Is it going to be a wireless network? Does that matter? If I have a wireless router, do they also have hardwired ports on them? Does that matter? So these are all things that I need to take into account. We kind of hit on this one before. You've got your ISP. You'll have the modem that connects you to the ISP. That modem then receives the IP address from the internet service provider, and it clones, your router would then clone that IP address on its external side and then share out subnets that's IP addresses that it's giving to the members of your local area network. All right. We've got things that are called routers, and we've also got things that are called switches. A router points people a certain direction. It's almost like a mail forwarder. You're going to forward mail to, all right, this person moved here, this person moved there, and it just directs things a certain direction. A switch works different. A switch, unlike a hub, it manages a lot of different ports, and it can secure certain ports, only have them available certain times and days, or only to certain people, whatever it may be. But a switch does not provide the IP addresses. It just guides traffic through the certain entryways. All right. I talked about DHCP, Dynamic Host Configuration Protocol. A DHCP server is integrated into most routers to where they dole out IP addresses. It's rare that you would see one without it. A WAP or wireless access point is your connection to that wireless system. Now, most wireless routers are also wireless access points. You can have a wireless access point that is not a router, though. It could be a repeater, which it just broadens the physical area of your wireless network. So, you know, I talked about before if you had, as opposed to a cable service, you had, say, service from AT&T or something along those lines. That connection, anybody remember what that connection would be called? So if your ISP was through your phone company, what was the connection? Do you remember that?
DSL?
DSL. So it's a digital subscriber link, as opposed to the connection that you would have to, say, Xfinity or Comcast. The DSL links, or digital subscriber links, those connections do not get repeated the way you would want them to get repeated. So at a certain point or certain node on the network, the farther you are from that node, the worse service you get, or the worse throughput, your throughput gets diminished. That's not necessarily the case if you get Xfinity. Wireless access points, we can run into problems because of the physical structure or infrastructure that you're having this wireless network in. These signals don't go through walls. They go around the walls. They go through openings that they can get through. The structure of different walls will diminish the signal, and you'll end up with bad signals in certain areas. You'll have, we call them dead spots. I get them all around the college. the way we avoid that is to put more wireless access points. And that is just the place where you access that wireless network. From there, we've got other things within the system. A firewall, I equate a firewall to a bouncer at the front door of a club. Nobody's getting in unless they get past that firewall. For a firewall to be successful, all traffic has to go through that one opening, or that firewall has to control all openings into the system. So if we use that analogy of bouncers at a club, if there was more than one door or one access point to the club, you got to have a bouncer at each door working excuse me, in concert with each other. And I apologize. I don't know if I can put my phone on silent. I've got to let it go. There it goes. So this firewall keeps things from coming in. One of the things that some run into, one of the issues that some will run into with MineTap is that you've got a firewall. And the firewall prevents not only things from coming in, but also prevents things from being stolen from inside. So what the analogy I used was that firewall is like the bouncer. Well, the bouncer's not just keeping people from coming in, it's also making sure the bartender's not slipping out with a bottle of booze that they didn't pay for or stealing. With that thought in mind, some folks had problems with MineTap where their security systems or potentially their firewall prevented them from having that connection with that external entity. All right. Here's examples of different kinds of access points. They'll have power connections, a place to turn them on and off, maybe a USB port, hardwired internet port that comes off of, and the example we showed before comes off of that modem. And then they've got four ports going into the LAN, local area network, that are access points for the devices connecting to the network. They've almost always got a reset button on them. And that's what you need should the person that set up the password for it no longer be with the organization. Just take a little pen or something and press that, reset it, password's gone, and then we get in from there. All right. So we've gone and bought one. We know what it's going to do, how it's going to work. We need to know, and I mentioned it before, we need to know the type of security that we're going to use. And when I say type of security, the encryption. How strong of an encryption do we want to have? If we're going to put a high level of encryption on these devices, that means everybody using it will have to adhere to that rule. Do all the devices that we want to have access this system, do they have that equivalent security measure associated with them? So that kind of goes back to that thing that I was saying before. The system is only as fast as its slowest component. System is only as secure as its weakest security component or the weakest level of security. I may have the goal of saying, all right, I want to have everything with the highest level of security we got available to us. But if I have one device that needs to connect to it that does not have that level, that device either doesn't get it or we have to use that level of security. One of the two. So there's a lot of assessment that needs to take place ahead of time, knowing what's going to connect to our system. And that'll help us determine what we're going to do. So these access points, the wireless access point or our routers, they have software associated with them and it can be updated over time. They have security associated with them. It wasn't long ago where some Netgear routers were actually getting hacked over the network because their firmware had been updated and hackers were able to get in from vulnerabilities that had been identified. So you want to make sure that your firmware or your software that runs these devices is up to date, it's current. Does the manufacturer still support it? If the manufacturer doesn't support it and the manufacturer is the one that is helping you stay current on the security, that becomes a vulnerability and we don't want to have any vulnerabilities. It's like you walking away from the house and leaving the front door wide open. Do not ever use that default password that they give you. Change it, make it something else. There's that rule, never write the password down. Well, that's all well and good until whoever came up with a password leaves. You know, don't write the password on the underside of the device, because all that means is if somebody gets have access to the device, now they have access to the device, software-wise. There are applications that will keep track of your passwords that have security associated with them. Great idea. So to configure the DHCP server, this is something that some of you may not have exposure to if you haven't taken CNT 2000 yet. In CNT 2000, you'll cover subnetting and how to break up a range of IP addresses into subnets. Well, let me kind of put it in a way that makes a little bit of sense to you, and I'm hoping it comes through right. So we have an IP address and we have a subnet mask. An IP address is like your phone number, your 7-digit phone number. Your prefix, mine's 239. A lot of people around here are 561s, 47, 305s, depending on what it may be. It doesn't mean what it had meant years ago, but in the past, that prefix meant you're in a logical grouping. Kind of meant where you resided. Everybody Palm Beach County at one point, we're all 407s. And if you saw that, you knew we were part of that group. So the subnet mask identifies the logical group with which those IP addresses are within. In that CNT 2000, you learn how to figure out how many addresses are within that logical grouping. And you can break it up into smaller little groupings if you want. But essentially, that's how it works. The IP address is kind of like your phone number in a way. You can't have a conversation without it. So your computer can't talk on the network without an IP address. There are some IP addresses that are set aside. We'll talk about that more in CNT 2000. And it essentially has to do with broadcast and your it's the lowest and highest numbers within the range. We'll just leave it at that. The wireless access point keeps track of everybody that is currently connected to that device. Kind of like if you did internet sharing on your phone, it would keep track of every device that's connected to your phone. Same concept. Now, in this one screen that we see here, they talk about MAC address. And I talked about that before. At least I think I did. Might have been in the 1150 class. Either way, I'll talk about it again. The MAC address is the physical address associated with your network interface card or network interface. It's in the past, it's a card. Now it's not necessarily a card like we had seen them in the past. So your network connection to your device, it's built into the device or it's an add-on. It could be a USB plug-in. It has a MAC address. That network interface also receives the IP address and subnet mask. All right. Let me see if I can, I'm going to show you something real quick here that may shed some light on this. I'm going to change my sharing to be this command prompt. Okay, so I ran a command prompt. I just went down into the search tool in the toolbar, or your taskbar, I should say. And I typed in CMD. It gave me a command prompt. So this command prompt is a way for me to go run specific commands to see what's going on my computer or built-in commands that I can execute. One of them is IP_config/ALL. The IP configuration, every aspect of it for this machine. I hit enter. And now here is all my IP data. Everything about any of the internet adapters or access points, or I should say internet adapters or network interface cards. So any of my connections. So it tells me the domain or DNS suffix, the domain that I'm part of, where I'm going to get domain name resolution. Now, a DNS server or domain name server is much like calling information on a phone system. I don't even know if it still exists. We look in Google now or look on our contact list. If you go in your contact list on your phone, you don't see a list of phone numbers, right? You see a list of names. If you click that name, it will show you the phone number associated with it. That's what a DNS server does. When you type in google.com, if you don't have it on your local list, it will go send a request out to the DNS server, said, hey, give me the IP address for google.com. Just like you call in information, say, give me the phone number for the local Waffle House. Boom, here it is. That's what a DNS server does. It's the information that you get is only as good as that DNS server. Sometimes you'll type something in and it comes back with no response because for whatever reason that DNS server doesn't have the equivalent of the phone number for the person you're trying to get hold of. Beyond that, so we've got the DNS suffix who we're looking for that DNS server. It's an Ethernet adapter. So this is a physical adapter. The physical address. So that is the physical address or the MAC address. You don't see the word MAC address on here, yet they talk about it in the text. We call it a physical address now. That's the physical address. It's unique. No other device has that combination. It is DHCP enabled on this network interface. What is the IP address? There it is. That's the IP address that's been assigned to this device. That's the subnet mask associated with that IP address. I've leased it starting on that date, and it's what's just over a week long is how long it's good for. What's the default gateway? What is, in essence, the IP address that I'm going to use to get out of the network I'm in and get somewhere else? What's the IP address of the DHCP server that gave me my IP address? And what are the IP addresses of the DNS servers that will resolve IP addresses to names or names to IP addresses? I can have more than one network adapter connected to a device. So I have different connections available, but they currently don't have IP addresses associated with them. All right. Let's go back to where we were. Okay. So that lets us know what this MAC address is. And if we're looking at MAC address filtering, essentially what you're saying is put certain restrictions on certain addresses, physical addresses, not the IP addresses. I can also do it relative to IP addresses, but on this, we can have access control based on the MAC address. Why the MAC address and not the IP address? The MAC address doesn't change. The IP address can change. So if I filtered by IP address, oh, you just lease a new one. Let me let go of it and go grab a new one. I can go in there on that command prompt, do IP config and release it and renew it and go get a new one. And it may not be the same one. Usually they give me back the same one. All right. Most of what we're getting today is just plug and play. There's the old thing we used to call it was plug and pray. You plug it in and pray that the drivers are good and that it will actually work for us. These are not all much different from one another when it comes to these wireless access points and wireless routers. You'll need to know how to configure this on the range of IP addresses. But since it's your local area network, it's not like you have to worry about, you've got a ton of devices going to connect to it. That's not to say that it won't. Okay. Now, we want to make sure that we treat our users much like AT&T treats their users. And I don't mean that in a malicious way, but what does AT&T do to their users when it comes to speed and bandwidth? They'll throttle you back if you use too much. So you don't want anybody taking over and using more of the internet or more of the connection than anybody else. So I can control how much access somebody has to make sure that one person's use of the network doesn't diminish somebody else's access. Trying to think of what it was. I remember a TV show where the guy's neighbor comes up knocking on the door, says, "Yeah, we got a problem." I said, "Well, what's the problem?" Says, "Your child's the problem." "What did my kid do? He hadn't been out of the house all day. He's attached to my network and he's downloading all this data, and I can't even watch Netflix or anything because he's just consumed all the throughput on my network." Well, the guy could have controlled that by changing the password and the kid can't get in. But in that example, you had one person that had access, for whatever reason, was granted access to the system and used it to the point that nobody else was able to use it because it was being dominated by one person. We only have so much throughput. Think about it like you got 2 lanes of traffic and all of a sudden one of those wide loads with a huge yacht is going down the road. I can't get through. I can't get around him. So the system is only as fast as its slowest component. One person has just slowed down the entire network. All right. I kind of talked about ports in the past. Port 80 and port 8080 are HTTP ports. They're web or internet ports. I don't want to say internet, they're web ports. The internet is not just one port. We've got a port where communication goes through for email. We've got a port for FTP, file transfer protocol. Different protocols are associated with different ports. And these aren't physical ports on the system. They are virtual ports. The fact that they're virtual ports makes it kind of tough to visualize how you're controlling them, but we treat it just like we were controlling a physical access point. So we can lock things down. We can say who gets access to it. If I've got a firewall, my firewall is where I will control what's taking place on those ports. If something comes through that port, I can forward all communication from that port to a specific device. We've got a term that's called demilitarized zone. In networking, that just means that there's an area of your network that the firewall's not protecting for whatever reason. It's not locked down. So I want to be careful about what's taking place in there. And I want to control what's coming and going from that area. All right. I can set up blacklists or whitelists, what can and cannot be accessed in my wireless access point. Setting up the wireless is much like setting up the wired, because you're controlling that access. The only difference is the wireless protocol associated with it. Everything else is pretty much about the same. This is where I was talking about your network is only secure as its worst security measure that you're going to allow access to it. Okay, there's a term, it's SSID, Service Set Identifier. That's the name of your access point. That's the best way to look at it. That's the name of your access point. I get a kick out of it for a while. I renamed mine just to confuse people around me, my neighbors. I don't know, sheriff's department, SWAT team investigation. And then your neighbors go to look to see what wireless access points are available, and that comes up. Wait a minute, the sheriff's department's over here? You can name it whatever you want to name it. You can set it to where that device is visible or not. Why would you want to have it invisible? I don't need anybody to know it exists. If it's visible, they can see what the name is. If it's invisible, you have to know what the name is. That doesn't mean you can't connect to it. You just need to know what the name is to be able to connect to it. We've got different channels on wireless networks. And it essentially means what frequency is the communication going to take place at? Is it 2.4 gigahertz or 5 gigahertz? And essentially what that breaks down to is how fast is it going to take place and the amount of security you can have connected to it, as well as the devices that you can actually connect to it. And this goes back to that same concept before, when I was talking about security. If you want to set it at 5 gigahertz and say we're only having 5 gigahertz connections, then if your device, somebody has a device that's 2.4 gigahertz, they can't connect to it. So it's whatever you set it at. The slowest frequency or the lowest frequency is going to be what you have to set it at. Okay, we've got a protected Wi-Fi protected setup, and the SSID is not broadcast across it. It's a special way to connect it to where the two systems start talking to one another. You'll initiate it, they'll start talking to one another, and it does it a lot of on its own, where you don't actually deal with it. But there's a pin or a key that has to, excuse me, take place in there. All right. Troubleshooting network connections can really aggravate you over time, because they can be tough to figure out what's going on. It could be a driver that's the issue. It could be a device that's failed. It could be a bad connection. There's so many different things to try and find out what it is. There's a utility built into your system that will help to try to troubleshoot what's going on. And that depends on the manufacturer and what they built into it. There's an option. We usually just go step by step, going through trying to troubleshoot what's going on. Now, you remember I showed you that command prompt. Here's examples of ping commands to where I'm pinging using that command prompt. And here's a command prompt right here where somebody's pinged an IP address. Think about it as there's a group of us in a room, and I want to get somebody's attention. I'm going to yell out to them 4 times and see how long it takes them to respond to me. That's what a ping does on the computer. Yells out across the network to a specific person, but it doesn't do it by name, it does it by IP address. So it would be like me yelling out somebody's phone number. I'll get a response. I yell out their phone number again, they get a response. Do it again. that response, how long it takes to get that response, gives me an idea of the efficiency of the network, how good is the connection, how much traffic's on it. Does it connect? Do I even get a response? What if I don't get any response? Does that mean the other end is not connected, or is it an issue at my end? It's all little things that I need to do to try to go through and troubleshoot these systems. I hit on this a little bit earlier, the IP config /all, that's what I did. Release, let's go with the IP address. Release 6, let's go of the IP version 6 IP address. Renew says go get me a new one. Renew, go get me a new version 6 address. Display DNS information and flush the DNS. Get rid of whatever we have in our, it's the equivalent of our local contact list on our phone. All right. Those are ways to go through and check to see what's going on with our network adapter and our network connection. We've got NS lookup that allows us to look up names of different devices and resolve them. Hey, what's the IP address for this? And it checks locally. We also have reverse lookup. Hey, here's an IP address. What's the name that's associated with it? Okay. Tracert is something that we use a lot in, some use it in CNT2000. We see it a lot in CTS1110 and those routing and switching classes. It's a way for us to see the path that these communications go through, how long it takes to get to certain points, and it traces the route of that package or that ping that we sent out in a way. So that we send the message out, where did it go? How many hops? How long did it take to get from one to the next? Where did it get lost? So it's sending back information along the way, and then you can find out where the issue exists. We've got different net commands to where I can go type in certain things and come up with, like I showed before, where I typed in CMD, it opened up a command prompt. I can do task manager. Another one that we can run is netstat and a command prompt, and it gives us statistics about that network connection. And there's different types of netstats, just like there's different types of IP config. So there's a lot of information when it comes to this one chapter. I mean, in a lot of chapters, I can get through it, about an hour and 15 minutes, maybe a little bit more, but not on this one, because there's just so much information that it's an entire class all on its own, or potentially it's more than one course, depending on how deep we dig into it. Don't take this chapter lightly at all. It's a serious thing. It really is. All right. All right. Let me pause the share. There's that. Okay, So we've dealt with this module 3, and I'm going to go dump a video in here, hopefully in the next day or so. It'll probably end up being more than one video, and we'll go into hopefully more depth than I went through this and add in tips, tricks, and insights. This one, we have a few more labs in here than we had in the past. So in this chapter, we've got 7 labs. There's a discussion, there's a test, and a reflection. How bad have the tests been? Do you think they've been brutal, or pretty much straight to what was in the text in that chapter?
Are you referring to chapter 2 or are you referring to
Chapter 1, chapter 2, the test overall?
I would say they've been relatively close to the lessons.
Awesome, awesome. So far, hang on, got a chat. Awesome. So yeah, pretty straightforward. I try to keep this stuff, I don't want you guys stressed out, so I try to do this stuff in a manner that keeps it fairly straightforward. But with that said, not everything's going to be as easy as we would want it to be. So what it said, as long as, here we go. As long as you did the labs and paid attention to the customer service labs, it was pretty simple. Customer service labs weren't as easy in some instances as we'd want them to be. It's one of those things they take a little bit of focus on them because of how they're just laid out, or how the instructions are worded. Awesome. How many? I don't want to put anybody under the gun on this, but depending on what sequence you took, you may or may not have taken CNT 2000. There is no requirement to have taken it yet. Those that have taken it find this chapter considerably more easy. I hear you. Are you talking to me?
I did took it CNT 2000 this semester.
So it should, this chapter 3 should be easier because a lot of it would be rehashed for you if you'd had CNT 2000. All right, what we got left? Let me know, like I said, the grading's all, I finished the grading yesterday. So if I missed anything in that first module on grading, let me know.